Assalamualaikum warahmatullahi wabarakatuh. Good morning everybody. My name is Maulana Daffa. Today I would like to talk about Tokyo Skytree Tower because this tower is the highest tower in the world. To start with, I will introducing the Tokyo Skytree Tower. Then I'll describe the structural scheme of Tokyo Skytree Tower and vibration control system are used on Tokyo Skytree Tower. And finally, I'll conclude my presentation. Just feel free to interrupt me if you have something to ask. Okay, let's get started with what is Tokyo Skytree Tower. Tokyo Skytree Tower, that completed in February 2012, is a new digital broadcasting tower for the Tokyo metropolitan area with a height of 634 meters from the ground up and planned as a new quasi-disaster prevention center and landmark of Tokyo. In the next slide, we will see what is inside of Tokyo Skytree Tower. Sorakara Point is a stage space built at the 451 meter high summit, surrounded by light and glass. Come see it for yourself to experience an amazing three-dimensional view that makes it feel like you are floating. You can even get a sense of the roundness of the earth. And Tembo Galleria is a glass-covered galleria. There is the Skytree shop on the first floor. Is the largest Tokyo Skytree official shop in the tower. And then there is Skytree Cafe. On clear days, this cafe provides a panoramic view of the Kanto Plain. And then there is Skytree Restaurant. The Skytree Restaurant is a restaurant that built at the 345 meter above ground. And here you can enjoy the most beautiful, wonderful time with breathtaking magnificent view. Now, we'll move on to the structural scheme of Tokyo Skytree Tower. The side of the tower is a former railway sending yard with the feature that it is long in the east-west direction but only about 80 meters in the north-south direction. In order to construct a building taller than 600 meters under Japan's severe natural environment, it is difficult to provide a plane shape at the base to securely withstand the horizontal forces when the width is not necessarily sufficient. To solve this problem, and as a result of considering various conditions, the plane shape at the base was chosen to be a triangular shape. On the other hand, as a result of considering the function of the observation deck at the upper level, the circular shape is desirable. As a result, Tokyo Skytree Tower has a unique shape in which the plane shape gradually changes from triangular shape at the lower level to a circular shape at the observation deck. This change in shape has an impressive effect on the tower silhouette. On the other hand, one side of the triangular shaped plane is about 70 meters or only a ninth of the height, which is a very severe proportion for resisting horizontal forces. The intention was to make the structural form as lightweight as possible, with a design that is not intimidating the surrounding area. So, a truss form was selected for the structural steel, and mainly steel tubes were adopted. The structural members. The steel members with the highest standard strength were the 630 MPa steel member for the base of the King Tower, which had a standard strength about double that of the steel used in ordinary 5 building. The member with the largest cross-section were 2.3 meter diameters, steel tubes used in the ridges of the tower at the lowest level, and the maximum thickness of the steel was 10 cm. Well, I've told you about the structural scheme of Tokyo Skytree Tower. Now, I will talk about vibration control system are used on Tokyo Skytree Tower. There's two types of vibration control system are used on Tokyo Skytree Tower. The first one is called TMD-S. On the top, that added mass control mechanism. As a tower that is used for terrestrial digital broadcasting, it is necessary to suppress the wind response of the gain tower at the top of the tower on which the broadcasting antennae are installed. Specifically, the velocity of the oscillation of the gain tower due to normal wind, which has a high frequency of occurrence, was required to maintain less than a specified value. For this purpose, two TMDS were installed on the top of the tower. The required performance could be assured with at least one device, but by providing the second device, higher performance could be assured, and it can be used as a backup in case of emergency. The second one is called the core column system, or core column type added mass control mechanism. The core column is used as the evacuation stairs and was a reinforced concrete cylindrical shaped column of diameter 8 meter, maximum thickness 60 cm, and height 375 meter. This column was connected to the main structural steel frame of the tower up to 125 meter above ground, and the portion above this height was connected to all dampers to suppress the motion of the core column itself. So it acted as a vibration control column that was structurally independent of the tower. This system is effective in various types of earthquake, such as long period earthquake motion and epicentral earthquake motion, and compared with the case where there is no center column effect. The response acceleration are reduced by maximum of 50% in earthquake and maximum of 30% in strong winds. This system is similarly with ancient technology from Japan that called Shimbashira. Okay, before I talk about Shimbashira, we will go to the next page. Shimbashira refers to a central pillar at the core of a pagoda similar structure. The Shimbashira has long been thought to be the key to the Japanese pagoda exceptional earthquake resistance. When the newer concrete building may collapse, the tower with many stacks of roof have a secret central pole called a Shimbashira that diffuses seismic vibration and keeps the whole thing from falling down. And the architect of the Skytree used a similar technology to secure the structure. A central concrete tube runs around almost the entire height of the tower. This tube is fastened to the side of the tower with 4 dampers. This allows the tube to sway without hitting the side of the tower. Now the tower should be capable of withstanding the strongest possible earthquake Tokyo could face, and will reduce the vibration from any seismic event by 50%. Well, that's all I can talk about Shimbashira. Finally, I will summarize my presentation. Tokyo Skytree Tower is a new digital broadcasting tower for the Tokyo metropolitan area with a height of 634 meters from the ground up, and planned as a new quasi-disaster prevention center and landmark of Tokyo. To construct a building taller than 600 under Japan's severe natural environment, it is difficult to provide a planned shape at the base to securely withstand the horizontal forces when the width is not necessarily sufficient. To solve this problem, as a result of considering various conditions, the planned shape at the base was chosen to be a triangular shape. On the other hand, as a result of considering the function of the observation deck at the upper level, a circular shape plane shape is desirable. As a result, Tokyo's Skytree Tower has a unique shape in which the plane shape gradually changes from the triangular shape at the lower level to a circular shape at the observation deck. Vibration control systems are used on Tokyo Skytree Tower. There is two types of vibration control system. The first one is called the MDS, and the second one is called the core column system. The core column system is used as the evacuation stairs and was a reinforced concrete cylindrical shaped column of diameter 8 meter, maximum thickness 60 cm, and height 375 meters. This column was connected to the main structural steel frame of the tower up to 125 meter above ground. And then Singbasira refers to a central pillar at the core of pagoda or similar structure. The Singbasira has long been thought to be the key to the Japanese pagoda exceptional earthquake resistance when newer concrete building may collapse. Thank you very much for your attention. Are there any question? I think there is no question. Okay, I will close my presentation. Thank you very much. Wassalamualaikum warahmatullahi wabarakatuh.